Okay, today I'm going to talk to you about the basics of waves. So we're going to look at the key features of a wave, and we're going to look at the difference between transverse waves and longitudinal waves. So to begin with, the very fundamental fact of a wave is it transfers energy from one place to another without transferring any matter. So it's just about transferring energy from one place to another. So I'm just going to draw a wave for us now, and we're going to label it. So 1, 2. Okay, so what we have right here is a wave. This actually is a transverse wave. So these top bits here, it's called the crest of the wave. You might have heard of this in surfing. And here, this bottom part is called a trough. This middle kind of section here is the rest position. So notice how the wave goes above and below the rest position. So like I said previously, a wave is how we transfer energy. In this case, energy is being transferred from here to here. So some other key features. Now this here is called the amplitude. So the amplitude is the displacement from the rest position to the crest. A really key one that we need to know is the wavelength. So the wavelength is the distance either from one crest to another crest or from one trough to another trough. Both of these show the wavelength. Just nicely put, it's the length of the wave. So it's measured in meters because length is measured in meters. Now what we also need to know is something called frequency. So the frequency is basically how many waves pass a point in 1 second. So if one wave passes a point in 1 second as a frequency of 1 hertz, let's say if 20 waves pass a point in 1 second, it would have a frequency of 20 hertz. Now let's say this particular wave we're looking at, let's say this is how many waves passed in 1 second. We could say, because there's 1, 2 waves, we'd say this wave had a frequency of 2 hertz. So that's what frequency means. Now the final thing we need to know about wave basics is this term, period. So the period is basically the number of seconds it takes to complete one wave cycle. So in order to find that, you do 1 divided by the frequency. So in this particular case, it would be 1 divided by 2, which equals 0.5 seconds, because it would take half a second for one wave to complete. So that is what period means, the number of seconds it takes to complete one full cycle. To find it, 1 over frequency. So what we're going to do now is we're going to look at the difference between transverse waves and longitudinal waves. So we've already had a look at a transverse wave, so we're not going to relabel this one. So the key things to remember about transverse waves is the vibrations for the transverse waves are at 90 degrees to the wave direction. So this is the big distinction, one big distinction between these two. So the vibration for this wave is going up and down, but the wave direction is travelling that way. The energy is being transferred in that direction there. So in a transverse wave, the vibrations are at 90 degrees to the wave direction. I remember transverse waves because they're the ones that look like they go from side to side. Transverse and side to side. So the examples, we need to know a few examples of transverse waves as well. So basically every single part of the electromagnetic spectrum, so radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, gamma rays, all of those are all transverse waves. Also, S waves. Now these are a type of seismic waves given off by earthquakes. Remember again, transverse S waves. That's a nice way of remembering it as well. And the final one we need to really, example we really need to know at this level is ripples and waves in water are also examples of these type of transverse waves. So now we need to learn about longitudinal waves. So longitudinal waves are really, really quite different from transverse waves. In longitudinal waves, what we have is we have a series of these things called compressions, and then these things called rarefactions, which kind of show what's happening. Well, let me explain. So when we have loads and loads of these waves all kind of compressed together, squashed up, this is called a compression. When we have this section here, where there is this kind of gap between the waves, this here is called a rarefaction. Now, again, we do have a wavelength within these waves as well, because the wavelength is the distance between two compressions. So just as before, the wavelength is measured in meters, because it's essentially the length between the waves, but it's slightly different than in transverse waves. Now, another big difference is in longitudinal waves. The direction of the vibrations are in the same direction, to wave travel, or the wave direction. So the vibrations in a longitudinal wave goes forwards and backwards like this, and the wave kind of travels that way as well, so that energy is transferred that way. So can we see it's completely different from transverse waves, where the vibrations are at 90 degrees. So just to finish up, the two main examples we need to know for longitudinal waves are sound waves, and the final one are P waves. Again, P waves are another type of seismic wave. So that's everything we need to know about wave basics and the difference between transverse waves and longitudinal waves. Thank you.